So let us graph the following function. F of x is 2x squared over x squared minus 9. So if we are looking at this even or odd, we can plug here minus x in every variable of x, and as we see, f of minus x is the same 2x squared over x squared minus 9. So this function is even. So it's going to be symmetric with respect to the y-axis. So now what we are looking here now. Let us find that finds the vertical asymptote. The vertical asymptote we find here, we take the denominator here, x squared minus 9, and we equate with 0. X squared minus 9, we equate this with 0. If we equate this with 0, we solve for x. X squared is going to be equal with a 9. So if we are taking a square root in everything here, so x is going to be equal with a plus minus 3. So it means that the vertical asymptote are two vertical asymptotes. X is 3 and minus 3. So let's draw here the 3 and minus 3. So this is vertical asymptotes. So if we are drawing here, maybe it's easy from the up if I'm going down. And so this is a vertical asymptote. So vertical asymptote is x is equal with 3 in this side. So it's a 3. So this is a x. And in the other side is the same thing. X is equal to minus 3. So there are two asymptotes. And let me draw this quickly. So x is equal with minus 3. So this is another asymptote here, vertical asymptote. And now we are looking for the horizontal asymptote. For the horizontal asymptote. The horizontal asymptote here, we are looking in this function. What we are looking in this function, we are looking for the numerator and denominator. We are looking for the degree, the horizontal asymptote. So the degree in the numerator is 2. And the degree of the polynomial in denominator is 2. Let me write, is the same, is 2. If we have the same degree, then the asymptote is from the leading coefficient 2 divided by 1 here. 2 divided by 1 is 2. So this is a horizontal asymptote. And if we are drawing horizontal asymptote here, is going to be as follows. So here in 2 is going to intercept, y is equal to 2. So let me write here horizontal asymptote. So just let me have here. So y is equal to 2. With 2, okay. And now I want to graph this graph of the function. But let me find the x-intercept. Let's say 3x-intercept. If we are looking for the x-intercept, we are setting y is equal to 0. And so y is equal to 0. If we are plugging here y is equal to 0, so we are going to have this way. 0 is equal to the 2x squared divided by x squared minus 9. But if I multiply f whole equation by x squared minus 9, whole equation, x squared minus 9 with x squared minus 9 cancels, and x squared minus 9 times 0 is 0. So we end up with 2x squared is equal to 0. From here, so 2x squared is equal to 0. Or as a shortcut, we just take a numerator and equate with 0 when we have cases like this case, what we have here. So x is equal to 0. So it means x-intercept is 0 and y is 0. So here what we have. And if I'm looking for the y-intercept, we are going to get the same y-intercept, okay? And y-intercept, I'm setting x is equal to 0. So like we do in an other function where we find y-intercept. And what we have here, y is going to be equal. Here on the top, 2 times 0 is a 0. And down is instead of x is a 0 here, minus 9. And what do we have here? 0 is divided by 0 minus 9 is minus 9, and 0 divided by minus 9 is a 0. So as we see here, we find out the same thing because we have here same. So the x and y intercept is to 0. So this point here. So already I have this point, just in one point. But I want to know here what's happening in interval from minus infinity to minus 3. Is going to be up or is going to be the down the graph? So I am plugging minus 4. If I'm plugging minus 4 to this equation here, minus 4 is going to be in square is a positive 16. 16 times 2 is 32. So on the top is 32. And here is a 16 minus 9 is a 7. So is a 32 divided by 7. So if I'm plugging, it's going to divide by 7. And if I'm plugging minus 1 here, is going to be positive 1. 2 times 1 is a 2. And here is 1 minus 9 is minus 8. 2 divided by minus 8, if I'm simplifying, is minus 1 over 4. So we are getting here. And of course, 0 if I'm plugging here, as we saw before, I'm getting 0. And same thing if I'm plugging 1, because it's even, I'm getting the same number, minus 1 over 4, like we did with negative number. And in the 4, I'm getting 32 over 7. So I have now those values here, and I need just one value here. Because I know in this side, minus 4 is going to be above 32 over 7 is a 4 point something, but is above the this horizontal line, which is 2. So, and now I'm graphing this function. When I graph this function, I know exactly if the end point here of the graph is going very, very close to the asymptote. And same thing is going to happen down here. It's going very, very close to this asymptote here. And same thing happen in the other side, because here is a 32 minus 7, further than 3 to the 4 here. And because it's an even, this function is going to go very close, in the same, and is symmetric with respect to the y. But what happened here is 1 is a minus 1, all right? So because the minus 1 is here somewhere, is down, and the same thing is in 1, and minus 1 over 4, if I'm plugging this point here, is right here. So now this has to go to this point, and then when go to that point is going very, very close by the end of the asymptote to the end points of the graph, going very close to this asymptote here. And same thing going to the right side, going very close. And this function, as we said before, is even with respect to the y-axis, and it goes very close to this asymptote here.